Bye, Stephanie. Have a good lunch. Okay, so picking up where we left off yesterday, number 3. So it says, suppose a culture of bacteria is put in a petri dish and grows continuously. So there's that word, continuously. So we're going to use PERT. The culture doubles every 4 hours. Write a function to model the continuous growth of the bacteria. Well, they don't give us a lot of information. They don't tell us how much bacteria we started off with. So it says the culture doubles. So we're going to pick numbers. So let's say we start off with 1 gram or whatever of culture. If it's going to double, we're going to end up with 2. So you have to put in the numbers. I like to use 1 and 2. You could start off with 2, and if it doubles, it would become 4. All right. So it doesn't tell us the rate, so we don't know the rate. It does tell us it takes 4 hours. So what we need to do here is, in order to write a function to model this continuous growth, we need to solve for r. So, well, since I used a 1, what I really have here now is 2e to the 4r, okay? Because 1 times anything is anything. So now we want to solve for r. So remember, since the variable is in the exponent, we're going to take the log of both sides. Well, since I'm using e, I'm going to go ahead and take the natural log of both sides. And bring the 4r down front. And the natural log of e, so the natural log button is right down here, Control, and then the E button. That'll give you the natural log. And E is found right here, the pi button. If you press the pi button here, okay, and then you're just going to go over and choose E, enter. The natural log of e, guess what? Is 1. So natural log of e is 1. So divide both sides by 4. So our rate is going to be the natural log of 2 divided by 4. And I'm going to go ahead and use all of those decimals in my rate. So 0.173287. I'm going to use all. I'm not going to round my decimals until the very, very end. Okay? So now that I know my rate, I can write my equation. My equation is going to be A of t equals the principal, the starting amount, times E, and then there's my rate. Now notice I have two variables, my principal and my time. Well, principal, remember they didn't give us a starting amount, so we just had to choose a starting amount. But in the following questions, we'll be given a starting amount. So for now, we're going to use this as our function. All right. If the initial amount of bacteria is 100, so we put 100 in for P, how many bacteria will there be after 15 hours? So, times 15. Plug it into our calculator. Show up here, 100 E, put all the decimals in, times 15. So it says round to the nearest whole number. So the nearest whole number is going to be 1,345. 1,345 bacteria. It's a lot of bacteria. Sorry, I'm trying to go back out here. When will the bacteria count be 350,000? Okay, so that's going to be based on a starting initial amount of 100. When will it be 350,000? So 350,000 is our ending amount. We're starting off with 100. We know the rate. And we're looking for time. So solving for t, first thing we do is we undo the multiplication. So zeros cancel, zeros cancel. Now, since it's a base e, we're going to use natural log on both sides. And bring our exponent down front. I'm doing 2 steps in one here. And we just learned that the natural log of e is 1. Dividing both sides by this decimal, by the rate. Alright, plugging it in. Natural log 3,500 divided by our decimal. So it's going to take 47 years. It doesn't tell us to round it. We could do 47.1 years. Approximately. Okay, moving on. Suppose you plan to invest $2,500 at an annual rate of 7.5%. How much will you have in the account after 5 years if the balance is compounded quarterly? So there you have it. Get our formula going here. Plug in our numbers. Investing 2,500. Rate, don't forget, divide it by 100. Quarterly, so that's a 4. 5 years. Okay. Plug this in your calculator. There's your answer. How long will it take to have 10,000 if the balance is compounded quarterly? Okay, so how long tells us we're looking for time. So we're going to end up with 10,000. We're starting off with 2,500. Rate stays the same. Quarterly. Okay, solving for t. So remember, to solve this for t, first thing we want to do is we want to simplify this here. So let's see what we get. So 0.075 divided by 4 plus the 1. So there's our base. Notice it's bigger than 1, so this is increasing. Okay, so next thing I want to do is get rid of that principal, divide. And 100 divided by 25 is 4. Okay, take the log of both sides and bring down the exponent. Now we want to solve for t. So many of you are doing this in 2 steps, so I'll do it in 2 steps as well. So we get 4t equals log of 4, it's base 10, so we don't have to put the number in there, divided by, and we've got this long decimal. Make sure you use all the decimals. Okay, and so we get this number here, so make sure you use all the decimals to the very end. Then we'll divide by 4. So time is going to be approximately 18.7 years. That's how long it's going to take to have $10,000. How long will it take to have $10,000 if the 2,500 is compounded continuously? Well, there's your key word, hurt. Okay, starting amount, 2,500. Ending amount, okay, we know the rate is 0.075. And it says how long, so we're looking for t. Okay, dividing first. I know I'm going kind of fast, so pause the video if I'm going too fast for you. Remember, when we're using e, we're going to use the natural log on both sides. Bring your exponent down. And the cool thing, and the reason why we do the natural log here, is because look what happens again. Natural log of e, 1. So t is going to be approximately natural log of 4 divided by 0.075, 18.5 years. Alrighty, so I hope you're having a good night. Make sure you have all these video notes done for tomorrow, and we'll see you in class.